Okay, so we're first going to go over the 2.1D homework, which you completed for your warm-up today. And for numbers 1 through 5, I've already circled the operation and I've graphed the two integers on the number line and noted which integer was first in the expression and labeled it as the start on the number line. So remember that I want to find the distance between the two numbers, and then I want to note which direction I'd have to go to get back to my starting integer. So for number 1, 4 minus 17, 17 and 4 are going to be 13 apart on the number line. And to get from 17 back to 4, I would have to go left, which would make that a negative 13 for my difference. For number 2, 5 and negative 10 are 15 apart on the number line. And to get from negative 10 back to my starting point, I would have to go right. So that would be a positive 15 for the difference. For number 3, negative 7 and positive 6 are 13 apart on the number line. And to get from 6 back to my start, which is negative 7, I would have to go left, which would make that a negative 13 for the difference. For number 4, negative 8 and negative 9 are just one space away on the number line. And to get from negative 9 back to negative 8, I would have to go to the right, which would make that positive 1. And for number 5, 9 and 4 are 5 apart on the number line. To get from 4 back to the starting integer 9, I would have to go right, so that would be a positive 5. So for the next group of problems, numbers 6 through 15, they want us to circle the operation and think of the number line rather than use one. They do tell us we can draw a number line if it is helpful, but I'm going to go through these without drawing a number line. So I have written the distance between the two numbers on the number line. So for example, number 6, 7 and negative 3 would be 10 apart. And to get from negative 3 back to 7, I would have to go right, and so that would make this difference positive 10. For number 7, 8 and negative 4 are 12 apart on a number line. To get from negative 4 back to 8, I would have to go right, and so again this would be a positive 12 for the difference. For number 8, 5 and 12 are 7 apart on a number line. To get from 12 back to 5, I would have to go left, so my difference would be a negative 7. For number 9, 6 and 18 are 12 units apart on a number line. And to get from 18 back to 6, I would have to go left, so my difference is a negative 12. For number 10, 14 and 3 are 11 apart on the number line, and to get from 3 back to 14, I would have to go right on the number line, so this would be a positive 11. For number 11, did that again. Number 11, 21 and 5 are 16 apart on the number line, and to get from 5 to 21, I would have to move to the right, and so my difference will be positive 16. For number 12, negative 13 and positive 17 are actually 30 apart on the number line. And to get from positive 17 back to negative 13, I would have to go left, making my difference a negative 30. For number 13, negative 8 and positive 3 on a number line are 11 apart. And so to get from 3 back to negative 8, I would have to go left, and my difference is negative 11. For number 14, negative 9 and negative 4 are 5 apart on the number line. To get from negative 4 back to negative 9, I would have to go left, and my difference would be negative 5. And the last one here, -2 and -6 are 4 apart on the number line. To get from -6 to -2, I would have to go to the right, and so my difference is +4. So when we're modeling subtraction on the number line, the first thing we want to do is graph the two integers in the problem, labeling the first integer as our start. And then we have to think about how far apart they are on the number line and which way we would have to go to get back to that starting integer. If we have to go to the right to get back to our start, our difference is positive. If we have to move to the left to get back to our start, then our difference is negative.